Okay, so let us try to understand what is Schottky defect, which is basically a point defect which appears in ionic solids. So to understand Schottky defect, let's first understand what is a lattice. So lattice is nothing but a regular repeating arrangement of something. Uh, something. So now that you understand a lattice, let us also understand what is a cation and an ion. For like representation purposes, it's going to be a cat and a dog. So now imagine a lattice like this, where there are equal number of cations and anions, except we are going to be making equal amount of cations and anions also be absent. So here one cation is going to be absent as well as one anion. Now, this is going to help us understand what is Schottky defect. So, what is Schottky defect? It is nothing but when equal amount of a number of cations and anions are missing from their regular positions in the lattice. So, if you might remember cations and anions, you will understand that cations have positive charge and anions have negative charge. So, what does this mean is that since there is equal number of them missing, the compound is still or the material is still electrically neutral. But since it is missing, the density is going to decrease. This vacancy is created. Alright. So now you might uh, ask where does this occur? So this occurs in salts like sodium chloride, potassium chloride, and cesium chloride. You might ask, why is this important again, or why does this matter? So this matters uh, because it helps us understand why real salts and ionic solids sometimes conduct electricity or why their density changes and it like their behaviors differ, how their behaviors differs from supposedly perfect ionic solids or crystals, perfect crystals. Okay, and so this is also important in material sciences, chemistry, and physics. Another question you might ask is, where do the missing cations and anions go? So these cations and anions go to the surface of the lattice, which usually go to the surface of the lattice. And this they leave behind vacant spaces, and since they're equal in number, the compound is electrically neutral, but the density decreases. So, example in NaCl, both Na plus and Cl minus go missing. Na plus is a cation, Cl minus is an anion. So that's that. Thank you.